That's your money saying it's time for a McDonald's run. Because with new McValue at McDonald's, you get more than you expect. Like buy a 6-piece McNuggets and add a McChicken for just $1. Your money says let's go. Get more than you expect with new McValue. Prices and participation may vary. Valid for item of equal or lesser value.
Hello, this is Dr. Kip Thorne, Professor of Theoretical Physics at the California Institute of Technology in Pasadena, California. And you're listening to the Dr. Sky Show.
Welcome, ladies and gentlemen, and welcome back to the Dr. Sky Show, heard exclusively here on Team Talk Network and on our flagship radio station, News Talk 1100, KFNX, the 50,000-watt powerhouse of the desert Southwest. By now, I'm sure you're all aware that the Dr. Sky Show concerns itself with serious science from the realms of astronomy, space, aviation, and weather. And today, ladies and gentlemen, in our allocated time slot, we're privileged and honored to have a very interesting guest, a fascinating guest, in my opinion, Dr. Kip Thorne, who's the Feynman Professor of Theoretical Physics at the California Institute of Technology, to discuss with us many of the current revelations in the world of cosmology and also in the world of physics. Dr. Thorne, welcome to the program.
My pleasure to be here.
Thank you, sir. And in this interview, many of the listeners, I'm sure, will certainly want to know, if they haven't already read this outstanding book that you wrote back in 1994 known as Black Holes and Time Warps, Einstein's Outrageous Legacy. And I was wondering, sir, if you could just tell us back then in 1994, what compelled you to want to write this book?
Well, I should begin by saying that that book was a labor of love over a long period of time. I began it in 1980, so it took 14 years to produce. Working, of course, part-time in my day job as a professor. My night job was writing. And I wrote it because I feel it's very important for us to convey to to American citizens, world citizens, the exciting science that my colleagues and I are involved in. After all, we have a pact between us as scientists and the citizenry of our nation, a pact in which the citizenry, through taxes, actually pay for the large fraction of the research that we do, and also through raising wonderful, brilliant children. They provide us with the students who come to institutions like Caltech, where I am, and whom I and my colleagues train to be the future scientists of the world. And so we really have a partnership with the citizens of our country, and a part of that partnership is for us to give back by conveying the excitement and the fascinating things about science that we have learned.
Well, I must salute you, sir, because, again, I said this off-air, but I want to thank you for spending the time with us today. This is a very interesting interview, to say the least, to be able to speak with you. And I'm sure many of the listeners, unfortunately this is not a live program, but many of the folks that are listening to this, I'm sure they will get a lot of valuable information, and especially, Dr. Thorne, the younger people out there, the new students of tomorrow. And what words of inspiration would you have for someone wanting to go into the profession as either being a teacher or someone going into theoretical physics?
I think all I would say is that it's exciting, it's fun, it's fascinating. When I was a child, my grandfather told me that if I found a job that was like play, that I would have succeeded in life. And boy, in this job, I really succeeded.
Well, I can say this is fascinating because here's another personal note, sir. Back in college, I remember as many students who were of age to have gone through college and going through the wonderful subject of physics. I can very vividly remember, though it's about 30 years for myself, a textbook that you yourself are part author, I believe, the basis of all of our study of gravitation, the textbook simply entitled Gravitation, by yourself, and of course by your mentor, John Wheeler, correct?
Yes, that's right. A man from whom I learned so much of what I now know about science.
Well, I want to be very honest, Dr. Thorne, about this, but I was not the A-plus student in this subject, but I must say it's probably still to this day, if I'm correct, is this the treatise on the subject as far as gravitation when it's taught?
I think it basically still is. There have been a number of books written since then, but they tend not to be as comprehensive at the advanced level as this. There are a number of very excellent texts at more elementary levels, and for anybody who wants to learn the subject at the undergraduate level, I wouldn't send them to our own book. I'd send them to a more recent book by James Hartle. But this does remain, in large measure, the standard advanced text in the subject.
Well, that's very humble of you, and we do appreciate your information today, sir. One of the things I would like to know, speaking of the subject, and remembering that this audience also may contain a lot of younger students, if you could, even for a person like myself that's not active in the world as a research scientist, how do you define gravity? The most complicated thing in, I think, most people's minds is, what is it?
Well, gravity, of course, we all know from everyday experience. It's the thing that holds us to the earth. It's the thing that brings us back if we try to escape. But it is much more than that. Gravity is one aspect, one of many aspects of warping of space and time, according to Einstein. And that's what has been so fascinating about gravity to me, is that it can arise as a consequence of warped space and warped time, and that there are so many other very different aspects of warped space and time that are intertwined with gravity when you get deep into the subject.
If I may go back to your past as you were a student, a young student, learning the subject, and your passion, of course, comes through, would you be kind enough, sir, to tell us a little bit about your mentor, Dr. John Wheeler? I mean, you're both Princeton graduates, and he, of course, is very, very well known in the world as what? Coining the term, actually, black hole itself.
Yes, among other things. Yes. So John Wheeler, who is still alive but is now in his mid-90s, was my principal inspiration as I became a working scientist. He taught me the theory of relativity, general relativity, Einstein's laws of warped space-time. He taught me how to communicate in large measure, how to write scientific papers, how to give talks that would be understandable to non-scientists. And he inspired me and other colleagues with a deep sense of what's really important that we should go out and study. He was the one who told us that there is a deep issue here in what happens when a star dies and loses the ability to support itself through pressure, because it cools off, the pressure goes away, and it implodes. And what happens at the end of that implosion, he argued way back in the 1950s, is that the implosion will make what he called in the 60s a black hole. And he inspired us all to go study this phenomenon. And those studies have led to wonderful discoveries about the universe.
If we go back to the concept of the black hole, and I'd like to get into that with you, with your permission, later into this interview in a little bit more detail, but the concept, even though John Wheeler, as we see, coins this term black hole, this whole concept of a frozen star, or a star that, of course, is similar to what we know of a black hole today, does this not go back to sometime, as I thought it was in England, where a research scientist actually came up with this concept in the 18th century or before?
So there is a variant of this concept due to John Mitchell back about, if my memory's right, about 1783.
I see.
Mitchell was working with laws of gravity due to Newton. Today we work with laws of gravity due to Einstein. Those laws are very different.
Right.
Mitchell, working with Newton's laws, realized that if you had a sufficiently compact body, it would pull so strongly that light could not escape from its surface. But he was using what we now know to be the wrong laws of gravity and the wrong laws of light. The remarkable thing is that in the modern era, when we got the more nearly correct laws of gravity due to Einstein and laws of light due to James Clerk Maxwell, that we get a similar phenomenon, the black hole. Similar in that the modern object won't let light out, just as John Mitchell's object wouldn't let light out, but completely different in its other properties. The modern black hole is made from warped space and time. Mitchell's black hole was just a very compact body that is pulling gravitationally. It didn't have anything like the richness that we have in the modern black hole with the slowing of time as you go down near the surface of the black hole, with time flowing in a direction that you would have thought was a space direction inside a black hole, with the black hole spinning and dragging space into whirling motion like a tornado. None of that was present in Mitchell's black holes because he didn't have the right laws of gravity.
Fascinating information here, folks. And if you're just joining us, ladies and gentlemen, we're conducting a very exclusive and special interview here on the Dr. Sky Show today with Dr. Kip Thorne, who's the Feynman Professor of Theoretical Physics located in Caltech in California, the California Institute of Technology, for our various radio stations, and, of course, our TeenTalkNetwork.com audience, and also on the various stations around the country that do, of course, air the Dr. Sky Show. My location is just a little bit south today of Los Alamos, New Mexico, as we continue with Dr. Kip Thorne on a wonderful discovery, I believe, ladies and gentlemen, on all of what's current today in this fascinating subject of cosmology, the latest in theoretical physics. We do have the expert today. Doctor, I was always told by other scientists that mathematics is pretty much an inspiration. It's pretty much a gift given to us from when we were formed and when we were born. But if you would just describe this process, I've read this in your book, that the process of thinking about these very, very technical subjects requires peace, of course, quiet, and concentration. And just like Dr. Wheeler, just like Stephen Hawking, and I'm sure yourself, describe this process. How did these ideas come to people? I mean, to me, I describe it as a genius gift, but maybe that's too simplistic. Please comment.
You know, different people's minds work in different ways. There's enormous differences between people like John Wheeler, who function on physical intuition, just a deep intuitive notion about what goes on in the universe. And another good friend of mine from Wheeler's generation, Subramanian Chandrasekhar, Chandrasekhar is the person for whom the Chandra X-ray satellite was named.
Yes.
And Chandra, as I called him, he didn't have an intuitive bone in his body. Everything arose from the mathematics for him. And so you have these two very different kinds of minds contributing equally to our understanding of the universe, but in very different ways. One guessing what answers are and then verifying them, the other digging them out of the mathematics. This ability to just guess without the mathematics is really a strong ability of that sort is very rare, and that is the inspirational thing of which I think you speak.
Yeah,
not that many people have that. I think more people have to work in the Chandrasekhar, in the Chandra manner, and you can get them out just from hard work with the mathematics if you're good enough at it.
Well, that brings me to your friend, Stephen Hawking, Dr. Hawking. And again, it's a privilege and honor to have you, sir, describing him and describing all of what's current here in theoretical physics and cosmology. But you are, as I understand, rather close to Dr. Hawking?
We've been close friends since we first met back in 1965. Stephen spends about 6 weeks a year here at Caltech with us. It's his home away from a home. And we're expecting him here for March and the first part of April this spring.
That is fascinating. And going back one more time to maybe his thought processes, his intuitive methods of which he goes out to enlighten all of us like yourself, it's basically from the book that I'm reading, again, Black Holes and Time Warps, Einstein's Outrageous Legacy, of which you are the sole author on this fascinating book. You describe in the book how he basically can picture and move around as if we're looking at, say, a Microsoft Windows screen, various thoughts, ideas, and actually do the calculations in his head independently of his body that suffers from ALS?
He didn't always do it that way. Back before he was severely physically handicapped by this motor neuron disease, some rare version of ALS. Back before that, I think his mind worked more nearly like the other people's minds. But as he gradually lost the use of his hands in the early 1970s, he had to develop a new way of thinking, and his new way of thinking was very geometrical. You can't do he could not, and I don't think anyone can do long calculations with formulas entirely in the brain. And since he was unable to write down formulas any longer with his hands, he developed the technique of doing his calculations mentally in his brain through manipulating geometrical images.
Fascinating.
Lines, curves, surfaces that intersect, that bend around upon themselves, things with different topologies and different shapes. And he, much of what we deal with in relativity is geometry. We deal with warped space and warped time. And so the ideas and the mathematics that we deal with, he was able to convert into shapes that he manipulated in his mind in order to see what was going on. He became much better at that than probably anyone else in human history, certainly than anyone else I've ever encountered. And his enormous contributions to science have come largely from thinking in this way. In some sense, his, as he himself will say, his debilitating, physically debilitating illness, he has turned into an advantage by using it as a motivation to learn to do things differently than the rest of us, and doing it so well differently that he can pull out things that we can't figure out by our techniques.
It's fascinating. And one other comment that, of course, comes very clearly through the book, Black Holes and Time Warps, is you describe Dr. Hawking, too, as having an incredible good sense of humor, and that comes through, if I'm correct, Doctor, very strongly. Is that right?
That's very much so. He has the biggest, brightest smile of anyone that I know. Although he has lost the use of his hands and his limbs, his facial muscles are still in very, very good shape, and his smile just brightens up a room enormously. When you have a conversation with him, the conversation is very slow because he has to speak through his computer, and he has to control the computer nowadays through facial motions of facial muscles that basically that are imaged by a photodiode. But he and so his speech is very slow. But when he speaks, you can't tell at the beginning of a sentence, is this going to be a joke or is this going to be something deeply serious? And the odds are pretty good it'll be a joke.
Well, that's fascinating because you can imagine minds like yourselves that are pretty much on a serious track and bent. Certainly the humor, I think, is what keeps things moving along.
Yes, it's very important, I think, for us as human beings, and he uses it to great advantage, and not simply in entertaining people, but uses humor as a way also of digging more deeply into issues that he's trying to think about or communicate about.
Well, it's a wonderful story, and Dr. Thorne, I want to go back, with your permission, back to your book, Black Holes and Time Warps, Einstein's Outrageous Legacy. I want to salute you for not only wonderful text, but I'm fascinated by the drawings that are also in this book. I think they're absolutely well done. The pen and ink, is that the basic description of how you would describe it?
Basically, yeah.
Very interesting. And folks, this is a book that if you're beginning your journey, whether a young student or even a seasoned, well-experienced individual, there is always something that you will learn, a new revelation, and something maybe especially for our younger audience, by getting a copy of this book, 14 wonderful chapters that go through, as you know, Doctor, better, the whole story of the relativity of time and space, the warping of space-time, and I could go on. But in the time allotted, I wanted to see, and there's so many questions, and I asked these questions of actually a studio audience that is not here, particularly made up of students and some senior folks that are listening to this. And basically, here are the questions, if you don't mind, just a few from the audience. One would be, if you would be kind enough to ask Dr. Thorne, how can he describe what is a black hole, and do we really know that they exist today?
Let me begin with the second question first.
Sure.
We have extremely strong evidence that black holes exist. I don't think we have any 100% incontrovertible evidence, but the circumstantial evidence is so strong that essentially every scientist who has looked into the subject is convinced they are there, and that we are seeing their influence in a variety of different places in the universe. So we've gone from wondering whether they exist to really exploring how they influence the universe.
Fascinating. And another question is coming to us, Doctor, that was already given to us before, of course, this interview, is basically this. As science continues to explore the very birth of the universe, how does the God equation fit into this? Are many scientists today now still looking at the fact that we still simply can't answer how this universe began, and thus there must be a more powerful being or some force that is behind all this?
I think there are many different points of view on this among scientists. Many of us don't see any need for God. There are others who see in nature around us the hand of God. Perhaps the greatest cosmologist of the 20th century, observational cosmologist, is Alan Sandage, who converted to Catholicism, became a very devout Catholic while he was in the most productive periods of his life. On the other hand, there are people, including me, who just don't see any sign of God present in nature. So this is a very controversial issue among scientists, and it indicates, in fact, that scientists are not all that different from non-scientists.
Oh, and again, we appreciate
with regards
your
to the
candor.
question of theology.
We appreciate your candor, sir, on this particular format in this interview. My concerns and my interest also goes to the concept here of talking about time machines, and you go through this toward the latter chapters in the book, Black Holes and Time Warps, Einstein's Outrageous Legacy. Tell us basically, in your opinion from the book, how probable is it, according to science, that a time machine could be created? And please tell us more on that.
Well, we've learned more as time has gone on. My book is now about a dozen years old. At that time, I would have guessed that it was unlikely, but not highly unlikely, that you can build machines to go backward in time. I present at the very end of the book a argument that I still hold to, an analysis that I carried out jointly with a postdoctoral student of mine who was from Korea, Sungwon Kim, in which we discovered that whenever you try to make a time machine, and by you I mean a very advanced civilization, no matter what technique that civilization uses, the time machine will try to self-destruct at the moment you activate it. In the book, I explain that we don't know for sure whether the explosion that must always occur, and that I explain in this last chapter, we don't know whether this explosion really destroys the time machine at the moment you try to activate it, or whether it's much too weak to destroy it. But there's been much work on the subject since then. There's another book that I recommend to your readers, a book called The Future of Space-Time, which is a collection of chapters by Stephen Hawking, myself, and others, that many of which are dealing with the question of time travel. And there you find Stephen Hawking at the end of his chapter, or in his chapter, describing a calculation that he has done using the laws of quantum mechanics, which are the laws that we now agree probably govern whether or not you can make a time machine. And his calculation gives a probability for whether or not a time machine could be made and I could travel through it. And that probability is unbelievably small. Now, he's using laws of physics that are not well established, because we don't understand these laws that govern this very well at all. But so it's just a tentative conclusion. But the direction he comes at it from, and that others come at it from, is making it look less and less likely that you can have time machines for backward time travel, but by no means ruled out completely yet.
Dr. Thorne, before we go to the top of the hour when we're forced to take our hard break, I was just wondering if I could ask you just a few more simple questions. I know we could go on forever, and I certainly would enjoy that privilege if there's another opportunity with your schedule in the future. We'd love to maybe do a more detailed interview, but thanking you ahead of time is great here on this program. If you could describe to us, sir, what would it be like for an astronaut if we could travel, let's say light speed, approach that area of the black hole? You describe, and I don't know if this is your terminology, but a spaghettification of what would happen to our body as we were pulled into this most powerful of all sources, I guess, in the universe.
So you can understand what happens by thinking about what would happen to you if you're up in the space shuttle, floating there. Your feet are closer to the Earth than your head is. And we know that, according to Newton, that because your feet are closer, they'll be pulled more strongly than your head. And Newton says that the gravitational force is stronger the closer you are to a heavy body. And so you'll be stretched from head to foot ever so slightly. So tiny, such a tiny difference you will hardly notice. When you get in a black hole, that difference between how hard your feet are pulled and how hard your head is pulled it becomes enormous, and you get stretched out to the point that your body begins to fail. You get torn apart, squeezed from head to foot.
Wow!
And that I think is an incontrovertible prediction of what's going to happen. That's not the whole story. When we look more closely at Einstein's laws of warped space and time, we find that deep inside a black hole, the structure of space and time is oscillatory, and what will happen to you as you fall into the hole, or happen to your poor dead body as you fall into the hole, is you get stretched from head to foot, and then a moment later you get stretched out the sides, and a moment later you get stretched front to back. And there's an oscillatory stretching in different directions, one direction after another, with the stretching getting stronger and stronger in these different directions until it's almost like you're being churned up in an old Mixmaster blender like my mother used to have when I was a child.
That's amazing. So it's a very violent, to say the least,
to say the least, process, and that's what the warped space and time do inside a black hole, as best we understand it.
That is amazing. Dr. Thorne, just a final one or two questions and basically some comments here. Basically, we're looking at now, since the book is back in 1994, Black Holes and Time Warps. If you'd comment briefly on these two new concepts. I was just reading a Scientific American article recently on dark energy and also this wonderful subject of gravitational waves. And if I'm correct, this is also some of your current research.
Yeah, so my own research is involved almost entirely in gravitational waves. These are ripples in the fabric of space and time that are created by things like colliding black holes and created in the birth of the universe that travel out through the universe carrying information about their sources. And they are the ideal tool for observationally studying black holes and for observationally studying the Big Bang. And so I was involved, together with Professor Rainer Weiss at MIT and Professor Ronald Drever here at Caltech, in starting a project to build large detectors for these gravitational waves that in order to try to see them and then extract this information they bring about what I like to call the warped side of the universe.
Wow.
Things made of warped space and time, like the Big Bang. We started that project in '83. The detectors are now operating at their design sensitivity, and the searches are underway. And it's a very exciting time for us.
I met Dr. Carl Sagan at Cornell University in 1984, as I'm sure you, of course, that's a little story that I'd like to explain to our audience, is that if I'm correct, you were involved in helping him for his then book, Contact, and then obviously a future movie, on this whole concept of time travel via wormholes. And if briefly you could just tell us that you were involved at least in advising him on such material.
Yeah, so we were close friends. When his book had been sent to the publisher, it was actually in galley-proof stage. He sent me a copy and asked me to read through his description where he had his Eleanor Arroway, the heroine in the book, traveling through a black hole. And so I read through it, and pointed out to him that inside a black hole you're going to get destroyed, just like we were just talking about. And if you wanted to use travel from Earth to some distant place in the universe through some kind of warp space object, it needed to be a wormhole. And so I sent him a little bit of mathematics that described the issues of that, and this became the foundation for his using wormholes in his novel Contact, and was in fact the way that wormholes then afterwards got into Star Trek and other places in science fiction, in modern science fiction in Hollywood.
Very interesting. And we always give our guests the last word, and Dr. Thorne, if you could just sum up, what would you like to see occurring here in our knowledge of the expanding universe? What would be something that you think is coming down the pike between yourself, Stephen Hawking, and also Dr. Wheeler in his senior years? What would be some great thing that you would love to solve or see happen?
The thing that I most want to see is a deep understanding of the birth of the universe. That will come, I believe, through a combination of theoretical work using laws of quantum gravity, most likely some version of what we call string theory, through a combination of that together with observations. And the key observations, I expect, will be gravitational waves. But the thing that I would really most like to know from science in my remaining years here on Earth is what were the details of the birth of the universe? How did it happen? And how is it that the universe came to be this glorious, beautiful universe we live in, beginning from a Big Bang?
Well, Dr. Thorne, we're right behind you. And again, I want to thank you, sir, for spending time in your busy schedule speaking to us on this most wonderful subject that I can feel the passion, and certainly I hope the audience is, of course, experiencing the same experience. That is a love of our universe, a love of knowledge, and the constant understanding and learning process that you're giving us here today in this interview. I want to thank you, and if you'd be kind enough, sir, to hang on just for a moment and stay with us just as we go to this break. I want to thank you again, Dr. Thorne, for joining us today.
My pleasure.
That was Dr. Kip Thorne, who is the famed professor of theoretical physics at the California Institute of Technology, speaking on many subjects near and far, and especially on his book, a must-read book, Black Holes and Time Warps, Einstein's Outrageous Legacy by Norton Press. That concludes this edition of the Dr. Sky Show, heard weekly on TeamTalkNetwork.com and on our flagship radio station, News Talk 1100, KFNX, the 50,000-watt undisputed powerhouse of the Desert Southwest, and the many radio stations that air the Dr. Sky Report. As Dr. Sky always encourages you, always keep your eyes to the skies. Thank you, Dr. Thorne.